Hello and welcome to our first Digital Learning Day lesson. Today we're going to go into geometry and we're going to be looking at the area of quadrilaterals. A quadrilateral, all that means is a shape that has four sides. Okay, we got different types that we're going to look for and that you're going to have to be able to find the area. So that is our goal. If you want, I would encourage you to take some notes as we go along, and then your homework will be Go Math for 13.1. It'll be a slightly modified assignment just because we're hitting the nuts and bolts of quadrilaterals. So there are three shapes we're going to take a look at today. The first one is a parallelogram. And a parallelogram could be in many different forms, but this is sort of a classic version of it, where you have two sets of lines that are parallel. And to kind of show that, we draw an arrow. So these two lines are parallel to each other, and then the top and the bottom line are also parallel to each other. And so that's what makes a parallelogram. Now, the way you find the area of this, to kind of show you how we do this, imagine we made a little triangle right here. And in class, if we had time for this, we would, I'd give you a parallelogram, and then I'd have you actually cut this triangle part off, and we would then take this triangle part, put it right there, and you know what you end up getting when you do that? You get a rectangle. So the way we find the area of a parallelogram is you simply take the length times the width. So let's do some examples. Let's say we have a parallelogram that looks like this. This side is we don't need to know the side length. We don't want the side length. What we want is the height. So let's say this is 4, and then there'll be a dotted line to show this is the height. Usually I put a little 90-degree marker right there, and say that's 3. So the area of this parallelogram will be 12 units squared, whatever it is. Centimeters, inches, feet, that's how it is. Let's do one more example for good measure. This time let's make it really long but narrow. So let's say that's 2, and this is 12. The area, you just take the length times the width, 12 times 2, and that's 24 units squared. So that's a parallelogram. The next shape is a rhombus. Now a rhombus is a special type of parallelogram. What it is where we have all four sides are congruent to each other. And in geometry, the way we show that is by putting a little dash mark next or in them. And what that's saying is that every line with that dash mark is the same length. Right, now, we're not going to get too much into how you find the area of this, more just kind of state how you do it. Not so much the why behind it. But you end up getting a couple diagonals. And so these lines I just drew here, they are called diagonals. And in order to find the area of a rhombus, what you do is you go 1/2 one of the diagonals times the other diagonal. Now, it's a lot of letters, a lot of fancy words, somewhat unfamiliar and not part of our everyday speech. So let's put some examples to this. Alright, so I'm going to try to draw it so they all look relatively congruent. And let's say that this diagonal right here, that guy is 15. And this one is a little bit shorter. Let's just say that is 10. So the way you'd find the area, you take 1/2, you times it by 15 and 10. Doesn't matter the order in which you do all this, so like 1/2 times 15, that doesn't work out that well, but 1/2 times 10, that's pretty easy. That's just 5. So we'll have 5 times 15, which ends up equaling 75. And so this one's going to be 75 units squared. And so that's how you find the area of a rhombus. Finally, we have trapezoids. Trapezoids are kind of cool. So, again, if we had more time, we're doing this digital learning style, we would kind of show you, I could show you and do activities that kind of make more sense why the area is what it is. But right now we're just going to explain how you find the area. So trapezoids have just one set of parallel lines. So those two lines are parallel. They're never going to touch. And we'll call the top one B1 and the bottom one B2. The other thing that we need to know is the height, H. And usually has that little box there to kind of show it's a right angle. Now, in order to find the area of a trapezoid, what you do is you take the average of the two bases, or you just add them up, times by 1/2, and you times it by H. So, taking a look at an example, let's say we had a trapezoid. One of its bases was, let's go 16, let's go 12, and let's call its height 4. So the area is going to equal 1/2, and we have to add 12 plus 16 times by 4. And if you just use parentheses, it'll make your life easier in terms of organizing it all. And so, do my order of operations. 1/2 times, here I'll get 28 times 4. 1/2 of 28 is 14, and I will times that by 4. And I get 56 units squared. So that's what your homework is going to ask you to do. Find the area of these three different shapes. Just to sum it up, the three shapes we have parallelograms. Their area is equal to length times height. So we have whatever this number is, your length, and then your height. We have, for rhombuses, that area is equal to 1/2 D1 times D2. And then for trapezoids, that's the longest formula, the area is equal to 1/2 B1 plus B2. So those would be the two parallel sides, B1, B2, times by the height. Good luck on your homework, and email me if you have any questions.